Hello, mere pyare bachcho, and welcome back. Your exams are just around the corner. I know. So you need to revise things quickly, right? Well, that's exactly what we're going to do. Today, let's just smash through this chapter on measurement and motion. We'll break it down into super simple ideas that you won't forget. Are you ready? Let's go!
Okay, so let's start with a little story from your textbook. Remember Deepa and her friends? They wanted to measure a table, and they thought, hey, let's use our handspan. Our belisht. We've all done this, right? But as they quickly found out, it kind of created a big mess. So what's the big deal with using a belisht anyway? Well, the problem is simple. It's not consistent. I mean, think about it. My hand is a different size from your hand, and your hand is different from your friend's. If we all measure the same thing, we're all going to get different answers. And that makes the whole measurement pretty useless, doesn't it? And look, here's the proof. These are the actual results Deepa and her friends got. Just look. Anish got 13, Padma got 14, someone else got 13 and a little bit more. See? For the exact same table, nobody got the same number. This shows you, clear as day, why using things like your handspan just doesn't work when you need to be accurate. This picture really tells the whole story. On the left, you have the handspan, what we call a non-standard unit. It's confusing, but on the right, you have a proper scale, a standard unit. It's clear, it's consistent. We needed a system where one measurement means the same thing for everyone no matter where you are. And guess what? We have one. And that brings us to the hero of our story, standard units. To fix this whole mess of different measurements, people all over the world came together and agreed on one universal system. This makes sure that, say, 1 meter is the exact same length if you're measuring it in Delhi or in Dubai. No more confusion. And the official name for this system is SI units. That stands for the International System of Units. And for measuring length, the most important SI unit you need to remember is the meter. Please remember this for your exam, bachcho. It's super important. The SI unit of length is the meter. Now, for your exams, you absolutely have to know how these units are related. It's really easy. For really long distances, we use kilometers. 1 kilometer is just 1,000 meters. Then, each meter is made of 100 centimeters. And finally, each little centimeter is broken down into 10 tiny millimeters. Simple, right? All right, let's talk about how to measure correctly, because questions on this come up all the time. 3 simple steps to measure like a pro. 1. Make sure your scale is placed flat, right against the object. 2. Look from directly above the mark, not from the side, okay? This avoids mistakes. And 3. If your scale is broken at the 0 mark, no problem. Just start from another clear mark, maybe the 1 centimeter mark, and then just remember to subtract that 1 centimeter from your final reading. Easy. But wait, what if you have to measure something curvy, like an arch or a winding path? A straight ruler won't work, will it? Well, there's a really clever trick for this. Just take a piece of thread, lay it carefully along the curved line, mark where it starts and ends, and then just straighten out the thread and measure it with your scale. So simple and so smart. Okay, quick pop quiz, exam time. Let's say your school is 1.5 kilometers away. How many meters is that? Come on, you can do this. We know 1 kilometer is 1,000 meters. So 1.5 kilometers would be 1.5 times 1,000, which is 1,500 meters. Shabash. I knew you'd get it. You guys are doing great with measurement. Now let's link this to our next big idea, motion. But you see, before we can even talk about something moving, we first need to know how to describe where it is, its position. To talk about position, we need something called a reference point. Think about it. If your friend calls you and says, hey, I'm 2 kilometers away. That's not very helpful, is it? You have to ask, 2 kilometers away from what? But if they say, I'm 2 kilometers away from the big temple, now you know. That temple is a fixed landmark. It's the reference point. Let's go back to our friend Padma. When she sees a milestone on the road that says Delhi 70 kilometers, what is it telling her? It's telling her position. Her location is 70 kilometers away from a fixed reference point. And in this case, the reference point is the city of Delhi. See how that works?
So what happens when Padma keeps traveling and the next milestone says Delhi 60 kilometers? What does that mean? It means her position has changed with respect to the reference point, Delhi. And that change in position, my dear students, is exactly what we call motion. It's that simple.
Awesome. So now we know what motion is. But, not all motion is the same. Let's quickly look at the three main types of motion that you see all around you every single day. Let's get moving. First up, we have linear motion. The name itself is a big clue. It's motion in a straight line. Think of a car driving on a perfectly straight road, or an apple falling from a tree straight down. That's linear motion. Next, we have circular motion. Again, the name says it all. This is when an object moves along a circular path. The best part is it always stays the same distance from the center. Like the blades of a fan, or your favorite ride at the park, the merry-go-round. That's all circular motion. And our third type is oscillatory motion. Now, this one is a repetitive back and forth movement. Just think of a swing in the park. It goes to one side, then to the other, and back again. Or the pendulum of an old clock. Tick-tock, tick-tock. That's oscillatory motion. Phew, we've covered a lot, haven't we? So let's do a super fast recap of the most important points for your exam. First, for correct measurement, always use standard SI units. Second, the SI unit of length is the meter. Third, we need a reference point to say where something is. Fourth, motion is just a change in position. And finally, the three types of motion are linear, circular, and oscillatory. That's it. Don't take any tension. Just remember these points and you will do great.
All right, my dear students, one last challenge for you. Right now, wherever you are, just look around. Can you spot one example of linear, one of circular, and one of oscillatory motion? Maybe the fan above you, or a needle on a sewing machine. Tell me what you find in the comments below. All the very best for your exams, study hard, and I will see you in the next explainer. Bye-bye.